Hello everyone, welcome to the Mammothon Tutorials. I hope you're all excited to get started. We're going to start off with a short introduction. So first of all, I wanted to introduce myself. I'm Rebecca, I'm the Programme Manager for the Mammothon from Encode Club. And I'll be in contact with you throughout the programme, and if you have any questions at all, then I'm the person to ask. So just send me a message on Discord or by email, and I'll try my best to help you out in any way that I can. So at Encode Club, we're an education community. We help you learn, build and forge your careers in emerging technology. We do this through educational events like hackathons, public education series, boot camps and accelerators. And we hope those of you who are new and joining us from the Mammothon will stick around in our community as you build and grow, because we're really excited to be part of your journey. So let's talk about the Mammothon. It's a really simple process. You have 28 days to build and ship your projects and be in with a chance of winning part of the $250,000 prize pool. So that is huge. The prize pool is going to be split evenly between the top 10 teams across all idea tracks. Now, this is where the Mammothon is a special event. In the Mammothon, you don't have to come up with your own project concept. There are Celestia Ecosystem partners who have shared ideas on what they want to see built on their tech stack. So they've given you all the resources that you need to succeed. You can build unstoppable apps, you can craft on-chain worlds, and you can upgrade the internet. The last thing to mention about the Mammothon before we move on to the tutorials is that in order to participate, you must be in a team of 3 to 5 devs. If you've not already, please read your emails for information on how to build up your team or how to register the other team members in your team to make sure that you qualify to compete in the Mammothon. When we launch, we'll have over 30 ideas, which means a few more are going to be announced very soon, so keep an eye out for that. And each one comes with a matching tutorial. This is really important. We want to make sure that you have everything you need to start the Mammothon so that you succeed. In these workshops, you're going to get all the essential technical skills that you need, and you're going to have the opportunity to ask questions and clarify requirements with each of the idea partners. Okay, so that is everything from me. Let's jump right in.
So I'm Norswap. I'm the founder of HappyChain, and HappyChain is a chain, as the name implies, for fully on-chain games. So these are games that run entirely on the blockchain. So all the logic will run on the blockchain. There's some interesting characteristics of what you can do with that. The one that excites me the most is that you can easily extend these games because they tend to be open source, and then smart contracts are like the best platform for interoperability, so you can build hooks and all the data is available, everything's on chain. We'll see that in the tutorial today. So HappyChain is for mostly fully on-chain games. I mean, it's a general blockchain, you can do anything you want, but that's what we're trying to push people to do. And that's also what we're building for. So the first thing we're building, actually, and the thing you'll see today, is a wallet that really helps with onboarding, because people might be motivated if they want to make a lot of money to set up a wallet and like wire money, etc. For DeFi. For games, onboarding is a little bit harder because people are like, they don't know if the game is fun, so they don't really want to install MetaMask, learn what seed phrases, open a centralized exchange account, wire money so you have money for gas. Like, that's super janky. So I'll show you today how we have this experience where people can just log in and play without like having to pay anything or install anything. Okay, that's for the intro, and then I will share my screen. I apologize in advance. We've been like crunching super hard to finish some of the features, so this presentation might be a little bit janky, but I hope you bear with me, and yeah, we'll have a good time and learn something. All right. There we go. So I am gonna take you first into a little demo app. Let's not do the picture because I think it renders. So this is a little demo app called Emojimon. So what I'm gonna show you today, there's two parts. There's the wallet that we've built, and then there is something called Mud, which is a framework for building on-chain games. So we don't build Mud, that's built by a company called Lattice. They're great guys. But I'll show you how we can use Mud and the Happy Wallet together, and explain a little bit how these games can be made. So what you see up here is a little screen of what you get when you log in. This is the Happy Wallet. So we're not connected right now. So what I'm gonna do is I'm gonna click connect. You see you have multiple options. You can use your existing wallet if you have one, or you can use Google. So you use Google. The existing wallet needs to be fixed, but we have a PR for that. But this is what works. Hilariously, we also inject our own wallet so that you can use it with things like Rainbow Kit or Connect Kit if you have that. But then we pick up on our own wallet, which also doesn't work, but it's kind of funny. So let's do Google. All right, let's log in with my account. All right, and so immediately what you see is that we're connected, and what comes up is this little, there we go, this little pop-up here. And what it's asking me is to approve a session key. Okay, so normally the wallet works like a normal wallet. So if you try to do a transaction, and maybe I can show you that as well. It will ask you for a confirmation, right? Like if you want to do this. If you're in a game, you don't want to confirm every time you move. That would be like a bad experience. So what we have is this feature called session keys, where basically this app, right here's localhost, requests permission to automatically do transaction for you on a specific contract. So this in particular is the word contract from us. It's the game contract. So I'm going to approve that. And it takes a little while. Okay. So now we're in the game. So this game is basically a very, very minimal clone of Pokemon, and we'll get into how it works. But basically, I can use my keyboard to move. I'm going to take it slowly because we have some issues with like the speed at which transaction. Oh, and sometimes when you move in a tree, you get an encounter like this. So there's a caterpillar, so I can try to catch it. So I do throw. And let's see what the result is. Oh, we missed, so let's try again. No luck. Last time I tried it, I called it on the first try. That's really too bad. Ah, there we go, we got it. So the game is very simple. Like, you basically saw the whole game, except that you can like just move. You know, nothing too special about that. You can move through rocks. You get a little message here. It's maybe a little small, but it says cannot move through obstructed space. So that's what it looks like. Now we're gonna see how that is being built. So let's pull up. Let's pull up the code. I'm gonna hop in chat to see if there's any comment on the setup because I haven't been looking. I hope the font is big enough, but if there's anything, I'll be hopping from time to time to check in. Okay, seems everything's good. Okay, so got a little README here, but basically what you need to run this, you need Node and PNPM, Foundry. I mean, I think you guys know all of that. And from a repo like this, we'll make a template repo available for you guys to use. So basically process pretty simple, PNPM install. Then you probably want to claim some tokens from the faucet. So users don't need tokens. There's gas sponsorship. You are the developer and you're going to deploy contracts. You need tokens to deploy contracts. So we have this little page here, and we'll link that in the documentation as well. We get your RPCs. You get the block explorer right here. You know, you guys like can add to MetaMask, but you get the chain ID. But yeah, basically the faucets, you can pop your address in here and get some Happy. Of course, it's a testnet. Your guys are the very first one to use this. I mean, we've done some tests, right? But like it's the first time it goes kind of public. So there's not a lot of transactions, so the fee should be pretty low, and the faucet should cover you for a long time. Okay. So you do that, and then the only thing you need to do is run pnpm dev for development mode, and that will bring up essentially this little this is a little program called mprox that runs multiple things in parallel. But basically, client is just serving your website, right? And contracts is deploying all the contracts. Here it had a little error because it was already deployed, so it's like, yeah, it's trying to redeploy. But yeah, so basically you can monitor here if there's any problem, and that's just like typing pnpm dev right here. So okay, how's this thing actually built? So I guess I should explain a little bit about what MUD is and how it works. So how MUD works is you define a set of tables, and these tables, you can think of them kind of like SQL tables, right? They have rows, which are like structs. And then all of these tables get synchronized to your client when you play. So that's at least in development mode. In production mode, you need to run an indexer that will do that for you, because you can create games that last a long time, and then synchronizing the whole state to your client could be too expensive. And from these, so here is the MUD config file. Like it's at the root of the repo. No, it's in the contract. So you got your structure here is you got this this mono repo with 2 packages, and the contracts package you get the MUD config. So in there, we're gonna define a few things. We're gonna define a few enums, and then we're gonna define our various tables. I'll go through them in a second. MUD is gonna generate from that, and this is all done automatically. When you run pnpm dev, like this is all done. But this is a file that when you're writing a game, you have to write things in here. And so what MUD is going to do is it will generate code for these tables, right? So there's this code gen repo. And so, for instance, we have, let's see, like an encounter. Maybe take a simpler one, encounter trigger. So it generates all this code that lets you access that, and we'll see what that looks like. So we don't need to worry too much about the generated code. But we'll see how we can use it. Every table has like a key. Every table is made of rows, right? And every row is a bunch of data. So for instance, if we take encounter, right? An encounter is when you encounter a monster, just like I showed like in the little demo. And basically every row is like a player exists. I'm actually not sure. I think it means is the encounter ongoing. The monster, and that's going to be a reference to the specific monster, and then how many times you try to catch him. And then specify the key is the player. So basically the way you look up these tables, you use a specific key, and in this case the key is the player. That's also called an entity, by the way. So that's an important term that you will encounter in MUD, like an entity is the key. One of the patterns for making games is this thing called the entity components bundle. And so these tables, they define components, and entities have components. So in this case, like a player has encounters. A player is also, for instance, movable. A player is a position. So basically you piece all this together to make the game happen. So this is tables, this is components, basically interchangeable. Like tables are used to implement these components with an entity key. And then you got your systems, which is actually your game logic. And let's maybe do the map system first. This is how you define your game logic, and MUD gives you a lot of convenience in doing that. So in this case, you have map system. and then defines a few different things you can do that are related to moving on the map, right? So there's a function to spawn. So I didn't show this, but when you first log into the game, you have to select a square where you're gonna spawn. And this basically does this. So you see it starts by creating an entity from the address of the player. And if we go there, this is just like, it takes the address and then it extends it to 32 bytes. So these entity keys, they're always 32 bytes. So we check that the player hasn't already spawned. We get the map config, and then we make sure that the coordinates are within the bounds. We also convert a position to an entity key. Again, these keys are like 32 bytes, right? So this uses getCheck to convert XY coordinates to an entity key. And then we also check that the spot that we check is not obstructed. So you cannot like spawn on a rock, for instance. Right, and see how this works. Like obstruction, again, is a table/component. We're using the position as a key to check if it has the property of obstruction. And if we go in our table here and we search for obstruction, you see this table uses like a complex table of this schema. If your table is like very simple, you can just specify it like this. So this has two things. It has a key called ID, and it has a simple property which I guess gets no name, which is a Boolean. And so basically we map position can be obstructed or not. Similarly, map config is also actually a table, and it's also an interesting one because it has no key. So that's if you want to store some like constant data, global data, then you can basically use a table like this, which has no key, to just like store these global values. And you see like get takes no parameter because there's no entity to look up. So okay, we checked all of this. Now we're going to spawn the player, and so for this we are gonna set this the player to true. So this basically means the player has spawned, like the player exists. And again, this is there's a player table in here somewhere, right here. We're also setting the position of player, right? So again, like these are all like the player is your entity, and then player, position, movable, and control, they are your components. So now we say the player is at this position, the player exists, the player is movable, and the player is encounterable, meaning it can like encounter monsters. Okay, I probably won't go into as much depth for the rest, but this, you move in a certain direction, it does a bunch of check on the player, it checks if the player can move. If you're in an encounter, you cannot move during that time. It computes the updated coordinates, bounds you to the inside of the map, and check if you're not moving into a rock. And then if not, it just like sets your position. And then finally, that one's interesting, is it checks if you should encounter a monster. So it'll check if you can have encounters, and then it'll check if the position you're walking in is an encounter trigger. Again, that is also defined as a table, which is the Boolean. And then, and basically on this little map here, the encounter triggers are basically the trees, right? Like you cannot encounter monsters when you're not on these trees. They're like the grass in Pokemon. Check, create a random number, like kind of pseudo random using the block hash and the preference DAO. And once every 5 times, you're gonna have an encounter. And then that's then we call this function right here. That's going to define the monster for the encounter. So we have this monster table. what's a bunch of them, but basically like, you know, the idea is you generate a monster and then you map it to its type component. So the monster ID is random. You set the monster type, and then you set the current encounter for the player. Again, player is the key, so the encounter is a component of the player. To the encounter data, that's like all these things. I'm not going to do the encounter system, but you sort of get the idea at this point of how the system works. And if you have questions, I'm very glad to try to answer them. So now that's the contract side, right? So let's have a little look at the client side. So this is a pretty regular React project. You know, starting from your index file right here. So what you can see here is that to set up HappyChain, it's actually super easy. We have an SDK for like plain JavaScript or TypeScript. We also have one specific for React, makes it a little bit easier to work with React. We're also working on a Vue.js SDK. So basically, you know, very classic, you just put your provider on here, then stuff happens in the app. Mud has a lot of setup, unfortunately. So what we'll do for you guys is we'll give you like a simple template, maybe just like this repo as a way to get started, but we're also working on a better Mud template that makes it even easier to define things without like having to dig in various places. But basically what happens here is for HappyChain specifically, use HappyChain hook. This gives you user information, and this would be like your account name and your account address. All right, and then this provider right here, that's how you connect to HappyChain, and that's something you can use with VM, you can use with WAGMI, Eaters, Web3.js if someone's still using that. It all works with this object, and I'll show you an example in the doc so you can set that up. Here in this Mud template, it's a little bit more involved, and there's a bunch of boilerplate to do that, but basically, we set the wallet here at some point. So basically, you know, the idea is like when you are in this app, right, you might not be logged in yet. And so the user in that case is undefined. So you need to display something when that's the case. And when the user becomes available, then we actually set the wallet to have the address in it. Okay, and then, you know, in terms of what you return, there's the Mud provider that's important for Mud. We, you know, define a little connect button. We actually have a little UI, but maybe I can show you later if there's a little bit of time for that. Then there's a loading wrapper because Mud loads, and maybe I can show you that. And then the really interesting thing, you know, is like this. Okay, use Mud as the main hook for Mud. It gives you access to a bunch of things. Here it's loading screen, so anything does the sync progress because Mud needs to sync. I'll show you. And then we go like into the game board, which, you know, is where the magic happens. Okay, let me check in on questions. All right. So, okay, let me do something dangerous and reload this thing. Okay, so what happens is it synchronizes with the chain. Right, this is why I say iterating for RPC, just like right now, pulling all the logs that it needs to rebuild the state of the game. Right. So that's what basically this little loading screen does. Yeah, something I haven't explained. It's quite interesting. Like I was, you know, I told you guys this was going to be very random. But the way Mud works is every time you modify something in a table, you know, say if you go to the map system, you're setting the position right here. So that will write to the state on the blockchain, but it also emits a standardized log message. And that log message is what the client uses to sync. It basically gets all the logs and then basically it replays all the state modifications locally. If you have an indexer, that's also what the indexer does. It just follows the events of the word contract and then it replaces the changes. So MUD, interestingly, deployed entirely within one contract with a bunch of other contracts like deployed, and then it delegate calls to these contracts. So like every system gets deployed separately, but the main word contract is kind of a proxy that will direct you to the right contract, but that's also the contract that holds the state. All the state lives into this word contract. I mean, this is like technical details that you don't really need to know, but this kind of stuff is interesting to me. Okay. Actually, maybe I can show you something related to this. So, you know, if you go in your little wallet, we have an activity view, and then you can use that to check on transactions from the Explorer. And then we can go to the log from this, you know, user operation. So I also didn't mention this, but what happens on HappyChain is everyone gets a smart account wallet, essentially. So there's a smart account deployed for you to serve as your wallet. And then the way you send transactions for this account is either use your existing injected wallet like MetaMask, or you log in with Google, and then later we'll add other like Twitter, Facebook, whatever. And we use that to derive a key. There's a bunch of people doing that. You might have heard of Privy. Right now we're using Web3 Auth. In the future we might use something else, but basically there's a way to, this is basically people authenticating you, and they generate part of your keys, and then you have part of your key locally, and then you just get these two together. That creates a unique key that no one can rug. And that key is what's used to send messages for the contract. You know, and I mentioned this because transactions for these smart accounts using the EIP 4337 standard, they're called user operations. So that's what you see here. User operation basically means smart account transaction. And so, okay, so we see this event from this transaction here, and you see it's that store set record, and this is a MUD log that says, hey, the state of this table has been updated to something. Of course, Blockscout does not know about MUD, so it cannot like tell you like which table or whatever. It just gives you the raw values. But I want to show that this is what was going on. Okay, let's get back into the, let me check on, okay, not missing anything here. Getting back into the code. So now we see this use MUD hook, which is really like this super important thing and gives you everything you need to work with MUD. And so it will give you this three interesting things. The components, which are, they're equivalent to the components we saw on the contract side. System calls, which are equivalent to functions that we saw in our little system right here. And then the player entity, which is 32-byte key that represents you, the player. So interesting note on this is none of this is actually like hard-coded into MUD. This is all defined in this MUD directory here. But basically every MUD project that is like ton of boilerplate that does all of this setup for you. But it could look different in your project if you wanted to. And when we're gonna do a template, we might make it look a little bit different. The important thing is, if you're in React, and by the way, you can use MUD, you don't need to use it with React. It can work with other things too. But if you're in React, you're basically gonna have a hook or a series of hooks, and they're gonna let you access your components, your system calls, and some special entities in some case. So the important thing is gonna be how do we define those? The components is really simple. Like MUD actually does all of this for you. So basically, you just get all the components that you defined in your. If you have too many things open in your mod config here, you just get those for free. What we do here is just do two other things. We define the player and the position, which already exist, right? But we define them to be overridable. Right? So we take the existing one from components, we've wrapped it in overridable. What it means is when you make one of these actions, you can override the state locally. And that's how this is smooth, right? Because if I move here, you see some log from the server come in a minute, right? So you see how long that took, right? But the move was instantaneous. And the only reason it was instantaneous is because of this overridable. This is sometimes called optimistic updates. So it's a way to, fake it until you make it. So you just show the change locally while it happens on the server, because that is latency. The other part, besides your components, is your system calls. Oh, that is not what I wanted to do. These are defined here and create system calls. And so if we go at the bottom, you see there's like basically 4 moves are being defined. Spawn, so select your location, move to move, throw the ball, flee. And these are just like, just very boring regular functions. They basically re-implement your logic. So remember, we looked at move. So it's just exactly the same thing as Solidity, but in TypeScript. It's not great. You have to do the logic twice. And I think in the future, we won't have to. There's people working on, for instance, EVM execution in the browser. So you could just like download the contract and run it without having to rewrite everything. Fortunately, for now, you cannot have to rewrite everything. I mean, you can also make simulation calls to the blockchain. It's slower, right? Because you have to go to your RPC. But if the logic is pretty complicated, sometimes it's worth doing that. So it's pretty much the same as the contract. We have this add override. So this is us being like, okay, we're moving there. We already know we're moving there. Let's update it on the screen before it happens on the contract. And then it ends by just sending a transaction. And this you also get from a hook, right? You get this word contract little thingy. And this has a read and write property, which basically defines all the functions available on your word contract. Again, this is done entirely automatically. So if you simply have your systems in here with your little, flee method, etc., that automatically gets included there. I don't even think you need to configure it in the mod config. I don't think. Yeah. So, okay, these are all your little methods, and then it's just like game implementation. Not gonna get too deeply in it, but oh wait, I'm gonna get deeply into this though. So we saw the use mod, right? But what I didn't see is this these hooks called use component value and use query. This is how you query the tables and the components, basically how you get your data. So in this case, okay, use component value. So we're using the player component or table with the player entity as a key. And we're getting the value. So remember, player was just like a Boolean that says whether the player exists or not. So we just get that. The other hook we have here, use entity query. So this basically lets you do kind of like a SQL query on your table. So you're querying for entities. Remember, entities are these 32-byte keys. I'm working for an entity that has a player. So it has a player component. So there's an entry in the player table. And it has a position. So there's an entry with this key in the position table. So it's going to filter all entities and then returns the entity that match this. And so that's how you get your list of players, because basically players are, they have the player component and they have the position component, and it's going to render. So this game is actually multiplayer, right? We didn't show that because nobody else is using it right now. But if someone else were to connect, there'll be multiple emojis. Yours would be the little cowboy, and other people will be this little funky dude with a mustache. We do more things. We get the map config again. We use this hook. If there's an encounter, so again, get the component value for the player, encounter. Will tell us about if the player is in an encounter or not. At this point, this is pretty standard programming once you understand how you query the components. Is there something else I need to show you? I am not sure. I am not sure. Let me tell you how to get documentation for all of this stuff. So obviously for HappyChain, taps.happy.tech, updated soon. Right now, tells you to install these things, but these npm packages are not deployed. But otherwise should be pretty accurate. We have a full automatically generated API reference for you to use. So it's all there. For mud, you go to mud.dev and you get the full documentation. So there's a little, if you want to learn more about Emojimon, there's a whole little guide which sort of takes you step by step in how this was built. They have the search is great. So if you want to learn about the mud config, you go here. That's going to explain how you define your tables, different options you can have there. Like in general, if you, what was it looking, before I was making this call, I was looking at something. I think I was looking data struct or maybe key, even a search like that. I don't know. If you search like data struct, be able to find explanations of what that does. Basically, instead of returning a struct, it returns that tuple in Solidity. So this is a great resource that you are probably going to use a lot. Yeah, I mean, I guess I have said the essential. Yeah, the wallet itself, super simple interface. You can connect, disconnect, you can get the user. You can, it has functionality, like wallet functionality. You can like watch tokens. You can even like set your own ABI so that if you do stuff like without the session keys, the games mostly use the session keys, but if you do like token stuff, or you can sort of like improve the display for users. You can trigger specific parts of the wallet. You can open at the send screen, which you can send yourself some tokens, stuff like that. And here, like watch token can be used here.